Gaussian noise and its implications. In signal processing, Gaussian noise refers to signal noise that's amplitude has a probability density function equal to that of the normal distribution. Specifically, in telecommunications, channels of communications are impacted by Gaussian noise coming from multiple natural sources. These sources include, but are not limited to, Johnson-Nyquist noise and shot noise. Johnson-Nyquist noise is noise generated from thermal agitation of charge carriers in any conducting medium. This causes small but detectable current flow. Johnson, throughout his work, shows statistical variability occurs in charge-carrying conductors, supplying random variation in potential between conductor ends. Due to the central limit theorem, with a sufficiently or substantial number of samples from the population, the amplitude of the noise will be normally distributed. Study of Johnson-Nyquist noise is usually focused on its effects within resistors which carry excess of noise. Thermal noise is only generated by the real part of impedances. Therefore, reducing resistance values within a given circuit can result in less noise, but the easiest remedy is to reduce the temperature of a system in question. Shot noise comes from the discrete nature of electric charge, whether it be an electron or a hole. Unlike Johnson-Nyquist noise, shot noise has no relationship to the temperature of a system and is dependent on the current flowing through the system. Specifically, shot noise is due to the discrete pulses of current. Each pulse is the transfer of an electron through a conductor. When a discrete packet of current is sufficiently small enough, the uncertainty shown by the Poisson distribution becomes significant. Shot noise in some cases is negligible. For instance, a conductor with 1 amp of current passing through it. We will observe approximately 6.24 times 10 to the 18 electrons per second passing through this conductor. If that amount were to vary by several billion electrons, the change would be negligible relative to the current. But in some cases, shot noise is very influential to a circuit's success. In the case of microwave circuits, which operate around 1 GHz, the currents are minuscule. Therefore, deviations of the number of electrons per packet of current has a higher significance. Suppose the mean number of electrons is 100, then the deviations are 10 electrons, which is 1/10 of the mean, or in this case, a tenth of the current, which is significant. Shot noise is hard to remedy when a nuisance. It is good to first identify shot noise's magnitude and its effect on your system because it might be negligible. Otherwise, reducing current or certain linear filters can assist in reducing it. Shot noise falls under the category of Gaussian noise because in a Poisson distribution, when the mean number of events per tick is high, the distribution tends to the normal distribution. Though sometimes insignificant, Gaussian noise belongs in discussions of engineering because of its effects on signals in semiconductors. In the future, when semiconductors get smaller, shot noise will impact tunneling effects increasingly, or in the use of high-frequency circuits, shot noise will have substantial effects on signals.